Hi everyone, welcome to the CBD delivered from my office. So we'll see how this goes, but hopefully it will allow for a bit more discussion because you're in smaller groups and you're in your department areas. And so with that in mind, the retrieval's a bit different today, and rather than being independent, it is more of a partnered task, but it is going to involve you still retrieving your knowledge. So pair up, socially distanced of course, and it's that technique of elaborate interrogation that I mentioned before, whereby you're really going to interrogate your partner's understanding of the work we've done so far on human memory and how our memory works. So I've suggested 5 questions there, and they are quite probing questions, but of course you could use some others of your choosing as well. So one person will obviously be answering the questions, the other person will be asking them, but that doesn't let the questioner off the hook, because when that process is finished, the second step is to then swap and allow the person who was asking the questions to then kind of report back and paraphrase and summarize everything that the other person had just said. So both people end up having to really explain and explore their understanding about the memory topic so far. So pause me, and there'll be lots of opportunities throughout this video where I'm saying pause me and do this, and just give that 5 minutes and have a little bit of a discussion around how confident you are on this memory and cognitive science area. Okay, so obviously I hope that led to some good discussion. The key things that you would have been looking to hear, I've kind of just highlighted in green there by way of some green pen, some suggested answers. It was of course Ebbinghaus who originally came up with the forgetting curve idea, and that was his very small scale piece of research. In fact, it began with just himself and thinking about how he forgot information so quickly, and then he tried to sort of take a scientific approach to it. But we know that there have been lots of more robust, larger scale studies since that have found very much the same thing, that we forget such a large proportion of information that we take in really quickly unless we do something about it. And that something is of course encoding, and that is that storing of knowledge in the long-term memory. And we know that one of the best ways that we can ensure that happens is to retrieve it, to force us to bring it back from our long-term memory into our working memory. And that process of giving ourselves time to forget and then having to try and remember, as hard as that is at first, helps that process. And we also know, as we've been talking about more recently, and I'll build on this again today, is that generative learning, giving us an opportunity to generate our understanding by linking our new learning to the current schemas that we already have, the pre-existing knowledge, that helps us with that process of encoding as well, because we've almost got a pot to put it in, we've almost got something to connect it to. Difference between cognition and metacognition. This is probably the area where staff were most vague, I would imagine, because we haven't done very much about metacognition, although some of you will have read more widely. So cognition is just thinking. So when we're thinking about cognitions, we're talking about, of course, memory. I mean, that's a thinking process in itself, how we store our new knowledge, and also perception, attention. All of these things are cognitive processes. But when we think about metacognition, it's the monitoring and controlling of that thinking process. So it's being aware that it's happening, it's being aware of when you're having to concentrate, when you're finding something hard. And we talked about that metacognitive cycle of monitoring, of planning, monitoring and evaluating last time. And I'll build on that again today. It was actually Pavio who came up with the original idea of dual coding, but probably the name that lots of people think of now, because of the work he's done in the education context, is Oliver Calviglioli. You know how I can't pronounce that name. And he is obviously brought into the forefront of teachers' minds, but it is a much older theory about this idea that we can benefit from dual coding. I mean, dual coding is something that happens in the brain. It's not something teachers do, but teachers can make decisions that allow dual coding to happen in the minds of the student, and that's by using that that visual loop as well as the auditory loop. So we'll touch on that as well. And of course, cognitive load theory developed by Sweller is this idea that our working memory, the bit that we're using a lot of the time, is limited in its capacity, and therefore if we're not really careful about how we chunk knowledge and how we present new information to the students, they will experience cognitive overload through no fault of their own. And we know we have to be mindful of that in our lesson planning as well. So lots to be mindful of. And this afternoon's session is about cognition and metacognition to a certain extent, and memory, and how we can take all of these findings from essentially cognitive neuroscience and our understanding about how the brain works and its role in learning, how we can take all of that and just make some decisions when we are planning our classroom practice. So a lot of it is reminders and it's things we've come across before, but I have tried to put a bit of new learning in there as well, so you don't get bored. Okay, so this is a bit of a cheat really, because I always show you this and then I always kind of zoom in on the bit that is focused on, but I kind of just put a circle around the whole thing today, because the whole idea of memory and cognition and essentially how our brains work doesn't really fit to any one particular category. If we get it right, it will benefit, and it kind of feeds into all of the learning principles that we keep referring to. So it's a bigger picture kind of focus this afternoon. So I've shown you this before, and I do this with students, and I think you should do it with students as well. You know, do not shy away from if there's an image which is great for sort of big picture and bringing ideas together, show them at every lesson. You know, if there's an inquiry question, we're going to come back to that idea later about having inquiry questions. But if there's something that just helps the students see how everything pieces together, then present it to them all the time until they get so used to seeing it that they too could explain that to somebody else. So this was an image that was used in one of Tom Sherrington's blogs, as I've mentioned before, and I think it just shows us the complexity of learning, not just how many distractions there are from the environment, and not just how our role as teacher in terms of the clarity of our communication makes a big difference, but also the inner workings of the mind and this limitation of the working memory, all of that. It's, you know, this constant kind of balancing act to get it right when we're in the classroom. And we recognise how hard that is, but there's things we can do to help once we understand how the brain is involved in learning. Okay, so I've shown you this before. I've got rid of my face so that you can see the diagram properly, but it's this idea of Mayer's soy model, so selection, organisation, integrate. And we know that if we want students to be helped with that process of encoding, we've got to help them integrate the knowledge that we're giving them in today's lesson, for example, with their already pre-existing knowledge that they've organised into schema. So we have to help them to organise their knowledge in schema by using graphic organisers or showing them the big picture, forcing them to make connections with the pre-existing knowledge, and then we have to help them to integrate it and give them opportunities to do that. And often those opportunities are through talking. Okay, so we're going to try a strategy, or you are, I should say, that's from the walkthroughs book. So you've all got a copy. So one of you could grab your copy and have it to hand for a little bit more detail on exactly how this works. It's page 70 to 71. And it's a strategy called Recount and Recall, and it's to tap into this idea of dual coding, that we can help students to encode knowledge in their long-term memory if we use dual systems. So we use the auditory and we also use the visual, and then they've got double the chance of encoding it. And I really like this idea, and I'm going to demonstrate it here in terms of the diagram, the picture that you can see there. So it's obviously relevant to what we're talking about, but you would do it in the context of a classroom with an image or a diagram that helps you to explain something relevant to your students. So it could be a diagram that helps explain a process, a concept, whatever would be appropriate. So the steps are really quite simple. You would have obviously given quite a lot of thought in advance to the diagram that you were going to use, and obviously that's nice to do that collaboratively as a team and think about what diagram best explains an idea, especially a complex idea. That's when this is particularly helpful. So you would construct it and you would explain it to the students step by step. So I'm doing it here with animation by well, that's bigging it up a little bit more than it really is, but slowly revealing parts of the diagram. If you were more confident than I am in terms of your drawing ability, you could literally draw it live. But as you're drawing your diagram, you're explaining it and you're showing the students why those lines are there, why you're adding that arrow, for example. And then the students take over at that point, but step by step. So we're doing it in nice small chunks because we know we don't want to overload. So you would do the first part of the diagram, and then the student would either have a copy of the diagram themselves or they would be asked to copy it, but actually giving them a copy and allowing them to trace over particular parts of the diagram saves any of that kind of extrinsic load of, oh, but I can't draw, and what should I use, a pen or a pencil? So actually, if you just give them it and they have to trace over as they go, that reduces all of that. So that you would do the first bit and they would trace over that first bit and have to explain to their partner that bit of the diagram. Essentially, they're just trying to rephrase what they've just heard you do. And you do that throughout the whole diagram. So in stages, slowly revealing the next bit, explaining it to the students, they explain it to their partner. Obviously, they can keep swapping, so everybody's talking. And then what you're working up to is that they can recount the whole diagram. So no longer in small chunks, they've done it all, they've heard it all, now they've got to do the whole thing, but whilst tracing it, and that helps to just activate that by actually having to really focus in on the diagram, and then at the end they redraw the whole diagram from memory and have to be able to explain it. And then without almost realizing, they think they've just been doing a bit of drawing, a bit of tracing, they've learned and explained and verbalized a complex process. So see it in action, I hope, and then there's going to be an opportunity for you to have a go in something a bit more relevant for your subject. Okay, so I'm going to demonstrate it here. So this is my student, let's call them student A, and what this diagram is going to show is just how complex that process of learning is, but what we can do as teachers to help support that. So the first thing for me to think about is how the environment shapes our learner and how much our learner interacts with that environment. And each of these dots here represents something else in the environment that is interacting with my learner. So that could be on our PowerPoint, that could be that we've got images that are actually a bit distracting and are kind of taking that person's attention away from what we particularly want them to concentrate on. So let's imagine that that particular dot there is the piece of learning that I really want their concentration and their attention to be focused on. But all these other dots around are competing for that attention. It's what other people in the room are doing. It's what people outside of the room are doing. It's things that are on the wall, displays. It's anything extrinsic or kind of extraneous on the PowerPoint or on the resources that might be competing for attention. So it's really important for us as teachers to think about that and think about where we're really focusing our students' attention. So there we have the word attention. Now at this point, if I was doing this as an activity in the classroom, I would stop and I would get the student to just trace over that particular part of the diagram and explain it to their partner. And you would do a little bit of paired discussion work on that. But I'm going to continue to show you how it might develop. So now we're going to look inside the mind of my student, and we're going to recognize that where the information you're presenting them with is firstly being processed is in their working memory. And we know that the working memory is limited in its capacity, and that's why we're representing it here as this sort of contained circle. It's only got a limited capacity. We can't go outside of that boundary. But also recognizing that as a human being, we have a long-term memory as well. And really we should allow this channel here to be open by deleting that top part of the skull there. because what we can do is we can make the most of this limitless, endless capacity of our long-term memory. We just have to help the students to move it from the working memory into the long-term memory. Again, I would pause and I would get the student to explain that next part of the diagram. So we're doing it in small, manageable chunks, which is obviously how we can help to reduce that cognitive overload, and we're getting the student to just deal with just very small pieces in their working memory. Okay, so then I continue. And I say, so we can do two things to help this process of moving things from the working memory, which is very easily overloaded, into the long-term memory. We can ask students to remember things, and that's that retrieval process. And that's really important that we select the right things, because that can help as well. That can help with that generative learning. That can help with them integrating the new knowledge with pre-existing knowledge if we get them to retrieve the right pre-existing knowledge through our retrieval exercises and through our questioning. So we can get them to remember things from their long-term memory, and that helps. We can also help that process of learning, and remember, you haven't learned something until it's secure in your long-term memory, by encouraging that process of encoding, and we know we can do that through dual coding. And that's it, my diagram's complete. I've slowly revealed different parts of it, given the students, if I was doing this in the classroom, an opportunity to talk to each other and to explain the diagram as it unfolds. And it is important that you're slowly revealing. In this case, I've just used simple fly-in transitions on a PowerPoint. If I was drawing it, if I was a bit more capable as an artist, then you're drawing it in stages, because that's the manageable chunks. And then they end up with the diagram, and they're working towards this idea of being able to do the whole thing from memory whilst explaining it. And then they've grasped a concept, a process that they didn't previously know. Okay, so following that demonstration, you can spend some time as a department thinking about a diagram or an image that you could either design if you haven't already got one in mind. So think about a concept in a forthcoming lesson, which maybe would really help the students if they had something diagrammatical, something visual to sort of hook ideas onto. Or you might already have one, a diagram that you've used for years, because it really well explains a process or a concept. And have a go at using that strategy, or designing a way that you might use that strategy with students in class, where you're getting them to take little bits of the diagram step by step and recount and recall it to their partner. So just spend a little bit of time as a department talking about how that may or may not work in your department. Okay, so I've just taken a couple of quotes here to set the scene for the sort of next part of this CPD. From a couple of things that I've read either recently or within the last year anyway. And the first one's from a really good book, Symbiosis, The Curriculum and the Classroom by Kat Howard and Claire Hill. And it's obviously, as the name suggests, it's a great deal about curriculum. But what it also does is it focuses, there's a chapter where it looks at memory in particular and why anybody leading a curriculum, and that's not just those with a title of curriculum leader, that's anybody who's organising a series of lessons essentially, needs to know about memory. And I quite like this quote: to ensure we use memory to our advantage when teaching curriculum content, we must plot out the connections that we hope to make between prior knowledge and that which is to be learnt. And I think that's really important. I've said it before, but when you're doing your retrieval tasks, it's thinking, right, well, what's the new learning today, and what learning would it be useful for them to connect that to? And therefore, that's the bit that I'm going to be expecting them to retrieve in the task, in the retrieval exercise, whether that's a series of questions or something more open-ended, but that's the bit I need to get them to move into their working memory. And then the other one, which I'm going to focus on for the rest of this session, is from that paper that Tom Sherrington referred to when he came to our school last November and did some training. And it's a paper by Arthur Shimomura, and it's a free online book, and I've put the reference to it in the PowerPoint so you could literally click and have a little look. And it's a paper which is entitled Marge, each of those letters obviously stands for something, a whole brain learning approach for students and teachers. And it really does, it digs into the neuroscience of our brain and looks at how just so many different parts of our brain, our reward circuit, our kind of anxiety center, everything is a factor when thinking about how we learn. Brilliant piece of reading. And you can literally take each letter from Marge and sort of deal with it in isolation, so you could read it isolated chapters, but if you look at the whole thing, it gives you a new insight into learning basically. And one of the things in there where he's talking about generating understanding and relating learning to previous schema is where he says the links that we create between new information and existing knowledge are as important as the new information itself. And we've talked a bit about schema building, but I think that really stresses it as well. So I'm going to focus on this paper, and there's the hyperlink there, and you guys have got the PowerPoint. So there might be opportunity for, as a team, you to kind of divide it up and each take a chapter in turn, and feed back to the group and think about the implications of what you read for your subject area, because I think there are quite a lot of significant implications. But it is this idea of a whole learning being a whole brain issue. And you can see there what each of the letters in Marge stand for. So I'm just going to build on a few of those, pick on a couple and build on it and give you some examples and some things to think about. So a question for you, a bit of a strange question, and it would probably be quite interesting fun to just pause this and talk to each other in your team. What do you think chocolate, cocaine and quiz questions all have in common? Okay, so pause me and have a think. So I'd be interested, it'd be nice if we were in the same room and I could hear some of the suggestions. I'm sure we would have some very good ones. But essentially what they all have in common is, and the biologists might have got this, is they all trigger the reward center or the reward circuit of our brain. So what you can see there on the screen is some fMRI scans, and they're showing the particular parts of our brain that we know are activated when you take part in an activity, basically, which rewards, which gets that dopamine going, basically, and which you therefore gain sort of intrinsic motivation from and satisfaction. And the quiz questions is obviously the bit that we're interested in here. There was a study that was done a number of years ago now, and Shimamura refers to it in his paper. And they found out that the more curious a quiz question or a question was, the more it kind of ignited curiosity in the human brain, the more we activated our reward circuit. So the more sort of pleasure and satisfaction the person gained from that. And that gives us this intrinsic motivation. So the M of Marge is motivation. And we know that we will be more motivated if we're curious. And you might think, right, okay, well, what's the implication of that for learning, for the classroom? Well, it can be as simple as inquiry questions. And this is not about suddenly saying, right, we're going to have some sort of inquiry approach to learning where you find stuff out for yourself. Far from it. But it's about just framing the knowledge of that lesson or that series of lessons into an inquiry question, a big question, because that sparks that curiosity. And, you know, we know, and it links to this idea of storytelling as well as a way of grabbing attention, because we know that stories, the brain, the human brain is actually sort of, it will favour remembering details from stories. It's sort of an evolutionary thing. And part of that will be because a story automatically gets your curiosity going. What's going to happen next? What's going to happen to that character? You immediately have those sort of curiosity questions, and that in itself provides intrinsic motivation. So we mustn't overlook the power of just framing the knowledge that we're going to teach our students anyway into an inquiry question, and the sort of the broader and the more interrogating that question, the better. So again, I'm going to provide a pause point and suggest that you might think of a forthcoming lesson or a series of lessons. And if it hasn't already got an inquiry question, think about how could we frame it around a question. Could it be? You know, it might not be appropriate for some subject areas. That's a discussion to be had. So I'll let you have a little bit of a discussion around that. Okay, so I want you to look at this image, take a really good look, and then I want you to tell the other person sat closest to you what you see. Okay, so some of you will have seen a circus, and you'll have seen this as being probably a seal balancing a ball on its nose, and this would be sort of like the circus leader with the whatever you call that thing, cane, and so it'd be in a sort of tent-like structure, seen from a circus. Others of you will have seen a dance, a ball. So this would be the lady here who's kind of wearing a lovely long dress, and she's holding out her hand to the man who is leading her in dance. And so you would have seen this more as a ballroom setup or some sort of dance hall. Now, you might think, why am I showing you this? What the heck? It links, we always do this actually with psychology students as part of a bit of an induction, because it links to this idea of attention, and it links to the idea of how our mind works. Because what you could do, and if we had have all been together in the room, I would have done it as a mini experiment, and I would have given half of the group the first statement and the other half of the group the second statement. And depending on what statement you read, you'll then see a different thing when I show you the image. So when we've done it with the students before, they all just have a little slip of paper on their table, and they have to turn the slip of paper over, not showing anybody, read it, really concentrate on it, put it to one side, and then you present them with the image and you ask them to say what they see. That schema that we're forming, or that idea that we're shaping in their head, goes on to then change the way they perceive the image. Perception is a fascinating thing, and it's a part of learning. And it's interesting because it kind of shows us this idea of a top-down approach, where the knowledge is at the top, and we use our pre-existing knowledge, and we have to select that to then deal with things of sensation, what we think, our perception, what we think we see. So again, this was something that was taken from Shimomura's Marge paper, and he used this optical illusion. Is it a duck or is it a rabbit? And there's hundreds of optical illusions out there, but what he's using it to demonstrate is that that piece of knowledge that you had, whether I give you the text about it being a circus or whether I give you the text about it being a dance, that knowledge shapes how you then look at it. And this is the same in terms of our attention or a child's attention when they approach our lesson. Where we want their attention to go, what we want them to pick up, when we're giving our explanations, when we're showing them a video clip, when we're presenting them with an image, will very much depend on the knowledge that they have, the top-down approach. And we have to help them to make that link and to activate that knowledge. So I quite liked that as a demonstration of that idea. So we've talked before about, very briefly, albeit, but we've talked about generative learning and allowing students to relate their new knowledge to the knowledge that they've previously had, to their schema. And this, again, taken from that Marge paper, just gives some examples, things that we've talked about before: graphic organizers, giving them opportunity to chunk information, so give it to them in small chunks and they have to see how it all pieces together, using metaphors and analogies. And it all just strengthens their schema. And the more I think about that, the more I think about this massively important role that oracy has. So this overlaps, the relate and the generate bit massively overlaps. And you know, we as a school, lots of you have said you're going to focus on oracy as an inquiry question, which is brilliant. And I do think this is going to be really powerful. You know, if we are increasing those opportunities for students to talk about what they've learned, to put it in their own words, to explain, to pause and to generate their understanding, then we're giving them that opportunity to really truly learn something. So this was a piece of text taken from the Shimamura reading, but I just highlighted in bold there at the bottom. We must evaluate our conceptual learning from time to time in order to maintain a healthy and proficient knowledge base. So we have to be given those pause points, as I'm calling them, to stop and evaluate and work out, have I got it? Do I understand it? Can I put it in my own words? Can I explain it to somebody else? And that's part of that monitoring. That's metacognition, monitoring of our thought processes. Okay, so we're coming back to this, and I've shown you this slide before, and it's this idea, remember this, you know, all of the work we've done on Rosenshine principles is very much what the teacher's doing, but let's not forget what is the student doing at any given point in the lesson, that generative learning, and that's the bit we can really focus in on. And the Marge reading gives us that idea about just why that's so important. So well worth a look, even if you just read the G chapter, well worth a look. And it fits in with metacognition, and another reference to a book that I'm currently working my way through, Fear is the Mind Killer by Dr. James Mannion and Kate McAllister, and it's very much about metacognition. Whatever term you want to give it, that's essentially what the book is referring to, the importance of metacognition. And I just think this is really useful for us to see that, you know, metacognition is that monitoring and controlling of our cognition, of our thought processes. Alongside that sits that self-regulation of motivation, feelings, behaviour. And you put the two things together, and that's the ultimate goal of an efficient learner, because they can self-regulate and they can think to themselves, how do I feel about this? Is it working? What learning process is actually going on right now? If it's working, I'm going to stick with it. And if it isn't, I need to stop and try something different. And I've got the sort of resilience to try something different because I can self-regulate my feelings. That's the ultimate goal. That's what we're aiming to get our students to be able to do. Okay, so I'm going to stop talking now, and the remainder of the time, however much time you've got left, because obviously you will have been pausing and stopping, is for you as a department to try and put some of this into practice. So essentially it's some time to do some collaborative lesson planning. And what I'm suggesting is that you would plan, or if you've already got everything planned, maybe just with a new lens review a lesson that is forthcoming for people. And based on these principles of Marge that we've talked about today, and all of this knowledge from cognitive science, just ask yourself and interrogate that lesson with a slightly different lens. So I've suggested some questions there that you might use, and I've reminded you of those key elements of Marge. You might wish to use that as a prompt. But just think about how you will plan a lesson and deliver it maybe differently based on this whole brain approach, thinking about activating that reward circuit, thinking about how we ensure the attention is in the right place, that we use that top-down knowledge to sensation kind of idea, think about that optical illusion. How are we going to make sure the students connect and relate their new learning to their pre-existing schema? All of these things, nothing dramatically new, just a slightly different approach and a new sort of piece of research to think about. So thanks for that. Hope that was helpful. I'll try and get around some departments, so I'll try and pop up and see how everyone's getting on. You've got the PowerPoint and the link to the reading, so I think you should have plenty to be able to have some really valuable sort of department discussion time following this. Okay, thank you very much.